the people join in. I guess they have already, the city session is going on. So they might join in a minute or two. So after that, we can start it. So before that, I'll just give you an idea how are we going to proceed for Maths 1. So normally we'll be having 3 sessions per week and 3 TA session also. Even more TA session can also occur. But we'll be having normally 3 sessions, Saturday, Sunday, and the third one will be on Tuesday. Okay. So one of the session we'll try to just wrap it up the summary part, like whatever has been discussed in the content, 2.5 hour or 3 hour of content that the prof has recorded. Okay, in the next session, we'll try to take your doubts mostly, even though in the first session also we'll be discussing your doubts, but second session will all will be whole your doubts itself. And then the third session, you'll be having the solve with us. Solve with us is something like we'll be coming up with some problems and we'll be solving some problems along with you. Okay, so this is how we are going to proceed, and this will happen per week. So yeah, this is how we are going to proceed. And then apart from this instructor session, you will be having 3, 4 TA session also. The timing is from 4 to 6. Okay. Those sessions mostly are related to doubts. They'll discuss each and every activity question, each and every practice questions, and then the graded also after the deadline. Okay. So this is how have planned to go ahead. Apart from these sessions, what I'll try to tell you, I guess exactly 1 month from now, you have the quiz one paper. For many of you, it will be a quiz one, and then for many of you, will be a entrance exam or the qualifier paper. Okay, so that will be the case. That is going to happen on 19th of July. The syllabus, I hope you're already aware of that. The syllabus will be from week 1 to 4. Okay, and then and yeah, so and there'll be per week you'll be having every Friday you'll be getting the content. I hope the last yesterday week 2 also would have got released. Okay, now I hope you would have not gone through, but at least now you are already aware of that. The week 2 content also has gone through. Week 1 was released last Friday, so every Friday the content will be released, and then we'll be having the live session as I told you. Okay, you'll be having some practice assignments. So activity questions also, like there'll be after every video you'll be having some 3, 4 questions that you have to solve it. Like it will be good for you if, let's for example, after watching the lecture you can just solve this those questions to understand whether like you're able to grasp the content that will be discussed in the session or not, like in the video or not. Apart from the activity questions, you'll be having practice question one. Practice assignments will be a practice assignment of some 20 to 25 questions that you can practice it out. And after that, you'll be having a graded assignments. So that you have to submit it. Okay. And I hope you already aware of that the graded assignment you have to submit it, because that is the criteria to write your paper, quiz one or the qualifier paper. So the 4 graded assignment that you will be keep on getting every week, that you will be getting, there will be some deadline to submit that, and you have to submit it on the portal. Okay. So those will be considered, evaluated or considered for your like whether you'll be able to write the paper, the quiz paper or qualifier paper or not. Right. There is some percentage also, like 40% of overall you should be getting. And then there are some basic requirement also. 3 out of 4 should be submitted, or 2 out of 4, that you can check it out on the grading document, how many of the assignment you have to submit it. Okay, this was the basic idea that I wanted to give you. Okay, now we'll start it off with the session. So I'll just go through the week 1 content very in like in a detailed way. There is nothing much difficult to understand from week 1, but even though I'll be going through, and I'll let you know which are the portions those are important for your quiz paper also. Like we'll start with the very basics, the natural number and all those stuffs, and then we'll be discussing about the relations functions. Okay. Okay, so shall we start the session? The content?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, thanks.
Sir, will we wrap up week 1 today?
Yeah, we'll be wrap it up week 1.
Okay. So can you please tell duration approx?
It will go till 8 to 10 it will go. So by 8 it will be closed, okay? Are you able to see my screen? Is it
Yes,
visible?
sir.
Yes, sir.
Yes, sir.
Okay,
Yes,
thank
sir.
you. Thank you, sir. Okay, so I already told you, I'll give you an idea about everything, okay, about the quiz paper and all. So you'll be having three quizzes. So three quizzes will happen. The first quiz is about to happen on 19th of July, okay? And then you'll be having second quiz that'll happen after July, maybe in the August it'll happen, and then you'll be having an interim paper, okay? Okay, so these three quizzes, and that is constant for each of the courses that you'll be doing, okay, here. So here the syllabus, mostly for maths, what I'm telling you, the syllabus will be from week 1 to 4, and the quiz 2 will be from week 5 to 8, and then here it will be 1 to 12, okay? So the final quiz or the interim, the syllabus will be the whole syllabus that we have taught from week 1 to 12, okay? In maths, you have generally 11 week only, so okay, but for most of the courses, you'll be having 12 weeks of content.
Sir,
Yeah,
sir, if I'm not able to listen to the class today, will I get the recording?
yeah, you will be getting the recording.
Where will I get it, sir? Where should I check for it?
Yeah, on the YouTube, you can check it out. In the YouTube, there is a ITMBS page or the channel. There, if you'll find maths one, you can get it.
Okay, sir. Thank you, sir.
Yeah, thanks.
And sir, this DPT
Yeah,
or this
yeah,
PPT,
I'll upload it and then make sure that it will reach out to you. So via mail or something, it will reach out to you. So what I'll do is I'll create one Google Drive and then I'll keep on uploading all the slides that I'll be using. Okay. So that it will reach out to you for sure. Maybe by Monday, it will reach out to you. Okay. You can just check
okay.
the mail.
Sir,
Okay?
where will you share the Google Drive?
I'll share it. I'll make sure that the team will share it to you via mail. Okay, because you have already the people who has already have a roll number. For them, it is easy because they can access. They can have a access of Discourse. On Discourse also, I'll be uploading this all, so they can access it from Discourse. But somebody will be writing the qualifier paper for them. I'll make sure that they will send it via mail. Okay, because all the mails the operational team has it. So what I'll do is I'll be keep on uploading. I'll make a Google Drive where we'll upload all the, like, as the week proceed, we'll be uploading the content that we'll be using during the sessions. Okay. So you can just make a pin of that and you can keep on checking there. Okay.
Sir, is it
Sir,
possible,
can I?
like you can send it on the chat right now?
Right now I can't send it. Maybe after the session I'll send it. Okay. I'll have to create that drive and then okay. So after the
Okay.
session
Sir,
I'll share. Or maybe in the what I'll do in the next session also, I'll keep on sharing the starting 2 3 sessions, okay, so that everybody will be able to have that link, okay, where all the this slides will be uploaded, okay.
Yes,
sir,
yes, sir, that will be good.
What?
so what is happening with the Google Drive, Google groups that I'm unable to join that? I do not know
The
what is
Google
happening
group,
with
okay,
that.
there is something called discussion forum also where you can ask your doubts. So there is something, I hope they would have guide you, like on the portal if you'll go, there is some link, okay, about the course if you'll go. And about the course, there is something called discussion forum. If
Sir,
you'll
has
click
the
there,
meeting started currently?
not start, yeah, it's about to start in a minute or so. So I'm just taking the operational doubt, somebody has it. Okay, so there from there you can have the access of the discussion forum, okay.
What's both the same thing?
This which one?
Discourse and Google groups are the same thing?
Yeah, it's the same thing.
Thank you, sir.
Okay.
Sir,
Okay. Can we start now?
sir, hello.
Yeah.
Sir, I have a doubt that I am a qualifier year student. Okay, so I am going to give the qualify examination,
Mm-hmm.
and my doubt is that first 4 week content will be completed till 7th of July. Yes,
Yeah, yeah.
and subsequently then after week 5 and week 7, sorry, week 6 content will be uploaded with according date, yeah, after like 7th of July. So so we will get that access of week 5 and week 6 content before giving that qualifier examination.
You will be
L-
having the access, but the paper will not be having the content from week 5, 6, 7. And
Yes, sir. That's all right. Because I want to continue from that same term what is going on right now. So
yeah, you will
that's
be having the access. Okay, if you'll qualify the qualifier paper, you will be having the access till the end if you want to continue maths one. So many of the student doesn't want to continue even though they have qualified. If let's say example they want to continue from the next term, that maths one course. Maybe they would have taken stats one or English one and all this term. They can want to continue maths one the next term, they can continue the next term. If you want to continue the maths one this term itself, you can continue. Okay. So week 5, 6, 7, 8 will be there on your portal if you pass it. Okay. After qualifying that. So
okay.
even though the
Yes,
content is released for week 5, 6, all those will not be asked in the paper. Okay. And the
yes,
deadline will be in such a way that after paper also will be given some time to submit the required 5, 6, 7, 8. Okay.
thanks, sir.
Okay, let's start it off now. I hope I have to, and I made a clarification also how are we going to proceed for the next 2, 3, like 3 months of like it's a try semester, so 3 or 4 months of semester it will be happening. Okay, I'll just give you a brief about myself.
Sir, I want,
Yeah,
sir, I want to ask one question that are PA and DA are enough for practice for qualifier
it
exam?
is more than enough. Like activity, you solve the activity. The first step should be to watch the lecture, then try activity questions. After every lecture, you have some 2, 3 questions that you try it out, and then you go to the practice assignment. You solve those, and then graded assignment. So this should be the method you should be. And then if you have a doubt or something, like you can just
Means, sir, they are enough practice
what?
set for the qualifier. They are enough practice set for the qualifier exam.
Enough practice? Yeah, those are enough for the qualify to qualify the exams. Yeah, those are enough.
Lecture P and GA.
Those are enough, more than enough. And actually, you will be having some questions exactly same from the practice or graded in the paper also. So you have to practice. There is no other option. Okay, if you're not practicing, maybe you can solve it in the paper, but you might lose some marks also in the paper because some paper, maybe 10% of the paper will be exactly same. Okay, even though sometimes the value will also not get changed. So it's good to practice all those questions, practice and graded assignment. Even though we have some more questions, extra activity, like there are some extra practice questions also. We keep on uploading. If you
Yes,
have
sir.
enough
The
time,
purpose of
you practice.
the purpose of GA I know is play important role in eligibility for writing exam, but practice assignment and activity questions are the purpose of practice only
Yeah, those are for practice only. Yeah,
to prepare for exam.
correct. Yeah,
Which type of question will come in exam?
yeah.
Sir, so for qualifiers, the qualifying exam and quiz one both are the same, or after quiz one we'll be
Both
having a
are same.
Okay, sir.
The quiz one and qualifier are same, na?
Yeah.
Okay.
Okay. So I hope I try to clarify all the doubts that you have it. Let's start the
Sir,
session. So
sir,
yeah,
I have a small doubt that, sir, only with the help of a graded assignment submission, we are able to get the hall ticket for the qualifier exam. Am I right or
yeah,
wrong?
yeah. You have to submit the graded assignment. Yeah.
Okay, sir. That's all. Thank you, sir.
Thanks.
Yes,
Okay.
sir.
So let's start the session. Okay. The other doubts I'll take it in the end. Okay. Otherwise, we'll keep on uh, like we'll just be taking the operational
Yes, sir.
doubts.
We can start the first.
Okay, so week one mostly it's a in the maths like the week one content is very basics, like we are just starting it off. So will be many a times many of the people you might be knowing all those stuffs, but then also you'll have to finish it off. Okay, I'll have to go through it. Maybe some peoples are not from the maths background, so for them it might be helpful. Okay, so you don't have to write anything in the chat box and all, like this is pretty simple or something like that. Many people are not from maths background also, who are also will be appearing for the paper. Okay, so for them also, like, everyone should be on the common ground. So we'll have to go through it, each thing one and by one. Okay, let's start it off.
Sir,
So we start with the number. Yeah,
sir, now in this class you will say from starting, sir.
yeah.
Okay, sir.
And sir, please explain the topic with questions, sir, because maths is very tough for me, it seems.
Yeah, I'll go through each and
I am
every.
not I am not from non-math background, so
Yeah, that is what I said. I'll go through each things one by one, and then in the end we'll see the doubts. If you have, you can just ask your doubt, whatever you're facing. Okay. So yeah, the first thing is the natural number. So you would have heard about something called numbers, like the number values that you count it out, right? 1, 2, 3, 4, those numbers. So the first thing is the natural number. Why this has been taught? See, many a times in the paper also will be directly written the n. Okay, so something x belongs to n. So you should be in a position to understand that the x tells you about the natural number. Okay, natural number. What are the natural number? Any number that you count it, right? Or from zero, right? All the values from zero, like 0, 1, 2, 3, 4, 5, all those numbers, okay, are the natural number. One thing many of you would have studied in childhood or maybe in class 10th or 12th, wherever, that whole number contains zero, right? But for our course, so it all depends on how the people take. Our prof has taken zero as a natural number, and you will understand it also in the later part of the courses why we have taken zero as a natural number. So do not get confused in any, like for this whole course or for the whole degree itself. Every time the natural number is written, you have to consider zero also as a natural number. There is nothing called whole number for our course. Okay. So natural number includes zero. It should be there in your mind. It should go to the table. Okay. It should be there in your mind. Okay. That the zero here is been included in the natural number. Then the next thing is the integer. Integer is something like not the decimal part, only the number that you can count it off, right? 0, 1, 2, even though the negative number also from minus infinite to plus infinite, but there won't be any decimal stuffs and all. So those are the integers represented by G, okay, or Z, that you many times we call it as, okay. So all the natural numbers or the negative part of the natural, like negative sign, if you are taking of the natural number also, that also is an integer. Then we talk about the rational number. There is something called rational number also. Rational number is pretty simple, represented with a term like q, okay. And natural like rational number are those number, any number that you can represent in the form of a p by q, okay, or like anything that should be in the form of numerator and denominator, and the denominator should not be equals to 0. Okay, this is what we call it as a natural a rational number. So p you can represent in the form of some p by q, where p is the numerator part and q is the denominator number, some number, and where the denominator, okay, the q is not equals to 0. Any number, if you are able to write it in this form, those are all rational number. Okay.
Hello, sir.
Yeah.
Sir, is it the revision session of week 1?
Yeah, you can just think of as a revision session of week 1.
Okay, sir.
We are just going through each and every term that has been discussed in the lectures. Okay.
Okay, sir.
Yeah.
Sir, today function will also be taught.
Yeah, those also will be taught.
Okay, sir.
Everything
So the
will-
same will be repeated tomorrow, sir.
What?
So the same will be repeated tomorrow, or tomorrow will be questions only?
Tomorrow you'll be having a doubt session. So whatever doubts that you have, that we'll be discussing tomorrow.
All right, sir.
Okay. Okay. Now the rational number, I already told you, any number that you can represent in the form of p by q, where q is not equals to 0, those are all rational number. Apart from those rational number, whatever is left, okay, those are irrational number. And there are two types of irrational number. Okay. So irrational number in different types of irrational number, but there's one thing that confuses most of the people. Okay. The irrational number, there's something called non-repeating and non-repeating and non-terminating number. So non-repeating and non-terminating decimal values are all irrational number. Okay. So there are something called terminating and repeating also. Those are not irrational number. You would have studied about, like, let's say example 10 by 3. When you write 10 by 3, those are rational number. Okay, many a times it is written in the form of 3.3333, something like that, right? You can't say it as a irrational number because you can represent that in the form of 10 by 3. Okay, 10 by 3 is not exactly equals to that number that you're getting, right? So that's why whenever, if you're able to write any number in the form of p by q, where q is not equals to 0, those are rational. For irrational number, apart from all those number, you have whatever real number, let's for example, just think of as a real number contains both rational and irrational number. So rational number has been defined, and then the remaining portions are the irrational number. Okay. So the examples are pretty simple. You go through many a times you write pi value, right? Those are like 3.14, and then it will keep on like non-terminating, and then it will not repeat also the values. Okay, and then similarly the root 2, 3, or the Euler's constant, right? So those are the values. Those are generally the irrational number that you generally go through and whenever you're solving any of the maths and all. So those are the things.
So I have a doubt.
Yeah.
Even though pi is non-terminating, we also represent it as 22 by 7.
No, those are approximately same. Those are not exactly same.
Okay.
Yeah, 22 by 7. You just write it in the form, like just for making your calculation easy, but it's not exactly same. So when you are writing 22 by 7, that's a rational number. But any pi value that you're writing, 3.14 and whatever number that you get, right?
Yeah.
Right? The pi that you are getting, right? That is irrational. Yeah.
Okay.
You got it right.
Yes, thank you, sir.
Sir, please also
So,
tell
sir,
important for qualifier.
Sir, I am asking that, so 3.14 will be also an irrational number?
3.14 is not a irrational. 3.14 you can represent in the form of a rational, right? 314 upon 100. That is not a irrational number.
Okay.
You got it right. Yeah.
Okay.
So since pi is more
Yes, sir,
the
3.14.
pi is
3.14.
non-terminating, therefore it's irrational.
What?
Sir, is pi irrational or 3.14 irrational?
3.14. See, 3.14 you can represent, right? 3.14. Can you write this 314 upon 100?
Yes.
So this can be written, right? P by Q, where Q is not equals to 0. So this becomes a rational number. If you are saying that something like 3.14 and then keep on writing the values, right? Though that becomes a irrational number, not 3.14. Okay?
Okay, sir.
Yeah, because those are non-terminating. Those are not like, it's not getting terminated, right? So because you don't know where it will be over.
So I am telling about, I am relating it with pi.
Yeah, pi, what is the exact value of pi? Pi, if you'll just try to write the value of pi, what will you get?
3.14 something.
So that something is what? That is not terminating, right? That is what I said right here. It has been written. Decimal, those are non-terminating and non-repeating. Those you can consider it as a irrational number. Okay. The value goes like 3.145. It will not be, you'll not get some exact value, right? Like, let's for example.
Sir, he's not talking about pi. He's trying to say that when we divide 22 by 7, it comes down to a repeating.
First of all, the pi is approximated to 22 by 7. Okay. So if you are
Yes,
writing
sir.
the value
That
to
is
20,
what
so
I
if you
want
have
to
been
say.
asked in the paper, okay, pi, then you can write it as an irrational number because the pi exact, if you'll just approximate this pi, right, you'll get it something like non-terminating number. But if you have been given 22 by 7, that's a rational number because 22 by 7 is, from the definition, you can see that 22 by 7 is a rational number. Correct?
Sir, we can also write
Sir,
E
if we have
1.414.
What?
Sir, if we have like 10 by 3, then also we can't fully divide it. So it also can be a
Definitely can.
non-terminating.
10 by 3 is a rational number. What is the confusion here?
It's repeating, so it's a rational number.
So here it has been written, right? There is something called non-terminating and non-repeating. So 3.33, the values are repeating, right? After decimal.
Okay, sir.
You got
Got
it,
it.
right? So where it should not repeat and not terminate, okay? Because if you'll just see the pi ka exact value, you'll see that those are not repeating and non-terminating also. That's why it's irrational number. Okay. I hope that is clarification now. Like you.
Yeah, sir. Sir, sorry to interrupt for one thing. Can I ask about that?
Yeah. What is the doubt?
Sir, so basically, I was seeing your notes. They are literally the understandable ones. Can you share the notes with us later on?
Yeah. I'll be sharing these notes here.
All right, sir. Thank you so much.
Thanks, sir. Okay. So I was telling about rational, irrational. So from this Venn diagram, you will understand everything. So natural number, I told you, right? Any number. So there is nothing called whole number for us from now onwards. So natural number starts with 0, 1, 2, 3, 4, whatever number that you can get it off. Then integer has the negative part of this natural number. Like if you'll just put the negative sign with this natural number also, then those are the integer. Okay, determine like written in the form of G or Z. Okay, and then you have a rational number that any number that can be written in the form of P by Q. Okay, those are the rational number that comes under the real number, because real number has both rational and irrational number also. And then apart from this real number, there are something called imaginary number also that you'll be reading maybe later part of your courses, maybe in the maths 2 and all, not even maths 2, but you'll be reading somewhere, okay, about the imaginary number. And that imaginary and the real, if you'll just combine both, those are the complex number. Okay, so the complex number includes all the numbers, real, imaginary, everything. So if you'll just from this Venn diagram, it will be clear to you. So which that's a natural number is included in integer, is included in rational number, is included in real number, is included in complex number. Okay. Clear?
Yes, sir.
Yes, sir.
Sir.
Okay. Let's move to the next part. So now we'll talk about the set. So the basic stuff about the numbers, multiplication, division, all those things you can understand from the lecture itself. Now we'll talk about some of the a bit important portion, that is the set, relation, and function. Those are the three important stuff that has been talked in week 1, and those are generally asked in the paper also. Okay, so you'll be asked about the sets. You'll be asked about the relation, the different properties of the relation, and you'll be you'll be asked about the functions also, different type of function. Not much detail, because again we'll be starting, once you'll qualify from week 5, again we'll start learning about the function in much detailed way. Okay, as of now you will just be asked about the function, like what do you mean by range, codomain, those type of stuff. Okay, so we'll start with sets.
So please tell important for case ones.
Yeah, I'll tell you. So as of now, whatever we were discussing,
Sir, these topics are more than confusing.
though more than
confusing.
More than confusing.
Yes, sir.
Where are you getting confused?
If these are confusing for you,
Sir,
then
in sets, in function, sir. In
okay, function we'll
topic.
discuss. Okay, I'll clarify everything. Okay,
Yes,
you'll not
the
get
different types of functions.
Okay, you will not get confused there. Okay, I'll try to make it simple. Okay, now till now it's done. So sets is nothing. So whenever set is something like a collection of well-defined item, even though you're writing something, right, in a form of a set, right? Anything you write it. Okay, let's for example you write it the days of a week. Okay, so Monday to Saturday or Sunday. Okay, those 7. So that you can just say that this is a set of the days of a week. Or if somebody asks you, can you write this, like what are the like months of a year, right? So January to December. Okay, those are the 12 items of a set that contains the name of the month of the year. Okay, so set is nothing but a collection of well-defined item. Okay, any item you can just keep it in the set, and then can be asked to tell the cardinality or the item number of items present in the set. Okay, there's no boundation as such. Okay, so it's something like a well-defined item, that's it. And there are some important things that has written here. Those are important. Okay, 3 things, those are important for a set. Items in a set are generally called it as an element also. You can call it as an item also of each set. So, and then order doesn't matter in a set. Either you write January, February, March, or you write March, Feb, or January. Okay, that doesn't matter. The order doesn't matter, because you have been just asked to write the name of the month starting from. Can you please mute yourself? Yeah, Vedanti, can you please mute yourself? Okay. So what I was saying is, even though in the set, when you're writing some elements or in the set, the order doesn't matter in a set. You can write it January, February, or March, February, or January. That doesn't matter. So order doesn't matter in a set. Okay. The second thing is, duplicate also doesn't matter. Even though you're writing March, Feb, and January. If you have been asked the cardinality of this set, you'll have to write it as 3 only. So the unique element that is present, okay? The duplicacy doesn't matter in a set. Okay, I hope that is clear. So set was pretty simple, the well-defined items that you write, okay? Example can be, you write the name of any, let's for example, tell me the natural number which are less than 10, okay? So you can just write it from 0 to 9, less than 10, it has been asked. Okay, so 10 items there. And that you can write it from 9 to 0 also, 0 to 9 also, that doesn't matter. So the first thing is the order doesn't matter in the set, and the duplicacy also doesn't matter. So whenever, and even though there are some duplicate items, like the repetition of the same items in the set, if you have been asked to tell the cardinality, you just count the unique numbers. Okay, that's the thing. And the cardinality is something like the number of elements that are present in a set. So here the cardinality is 6. You can just check that 1, 2, 5, 7, 9, 300. So those are some sort of a set where the cardinality is 6 because the unique number is 6 here. Okay, same is the case for the A also. A is a set that contains some sort of a name and then a pile. Okay.
So please give us some time to write it down.
I'll share you this slide, so you don't have to write it. Okay.
Sir, where we can get those
I'll share it in after the class. I'll share. Okay.
Hello, sir.
Yeah.
So I have a doubt on this.
Yeah,
This
go ahead.
part. That cardinality of a set, you told that is what finite set. But if we get infinite set in the questions, in some questions, then what is the cardinality of this?
That will be infinite, right? What if they are giving infinite number of sets, right? They'll not be asking you the number of the number of items present or the number of element present, right?
No. If they ask, but not in quiz one, in any exam, if they ask them what is the answer to this?
What is the answer of what?
The cardinality of infinite set.
That will be infinite, right?
Focus.
Because the number present is infinite. So let's say example, you have been asked to create a set.
Yes, sir, I am asking about the symbol. That non-defined or infinite symbol will be used there.
No, you are asking cardinality. Cardinality is the number of items present in any set. Okay, let's say example, somebody is asking you, can you create a set contains all natural number? Okay, and then you have been asked, so what will you do? You will write it from 0 to infinite. Now you will be asked to, what is the cardinality of this set? What is the cardinality? There are infinite number, right? Infinite natural number. So the number is infinite. Okay.
Yes. Thank you, sir.
Thanks. Now in a set also we read about something called subset and a proper subset. Okay, it's pretty simple. Subset is let's for example, you have a set X and a set Y. Two set has been given to you. So here in the example you can see there is set X. Okay, and then there is set Y. Okay, and then subset is defined as a set X is a subset of Y if every element in X is also the element in Y. So that means it's simple. Like if you have been asked, and this is how it is represented. X is a subset of Y. That means what? All the element in X is also present in the element of Y. And if I'm representing Y is a subset of X, that means element in Y is also in the element of X. Okay, that means here the element, the number, let's for example, the cardinality is 5. So what will be the cardinality of Y? Can somebody tell me?
5 or more.
More than 5.
5 or
5
more.
on. 5
Correct?
or more.
5.
Yeah.
5.
5 or more, because subset, right? I just told you the element in X should be there. For sure it should be there in Y, but there can be some extra element also in Y. Correct? Let's for example, X is 1, 2 and Y is 1, 2, 3, right? Is X the subset of Y?
Yes, sir.
Yes, sir.
Yes, sir.
Correct. Right? And you can see that here the cardinality is 2 and here the cardinality is 3. right?
Yeah,
That is
yes,
what I
sir.
was saying. If X is a subset of Y, here if the number is 5, that means Y should be having the cardinality 5 or more, correct?
Yes,
Clear?
sir.
Fine, sir. Yes, sir.
So if, let's for example, X is 1 and 2 and Y is also 1 and 2, is X a subset of Y?
Yes,
Yes,
sir.
Yes, sir.
and Y is
Correct.
also a subset of X.
Y
Yes,
is
sir.
also subset of.
So for this one, tell me which of the following statements are correct. The first statement is X is a subset of Y, and second statement is Y is a subset of X.
So
Sir,
both are
both are
correct.
correct.
Both are correct.
Both are correct, sir.
Correct.
Both.
are correct.
Both are correct. Yeah, nice. Okay, so the first thing that we learned about is a subset. And what we have studied, set X is a subset of Y if every element in X is also present in Y. Okay, that is what we have studied. So first thing is simple. Now there is a something called proper subset. Okay, this is how generally it is represented. Like almost same, just the equality sign is not here. Okay, and here you will
Sir,
understand that proper subset, when we read proper set, is something like the set X, okay, is a proper subset of Y if X is a subset of Y but X is not equals to Y. The equality condition doesn't hold. So the second example that we took, right, X has element of 1 2, Y has element of 1 2, so X can be a subset of Y but X is not a proper subset of Y, right? So okay, I'll give you an example. Let's, for example, the same example I am giving you, X equals to 1 and 2, 2 is Y equals to 1 and 2. Now tell me which of the following statement are correct. X is a proper subset, sorry, X is a subset of Y. Second is X is a proper subset of Y. Which of the two
Subset.
are correct?
First one
X
is
is a
correct.
subset of Y.
The
First one.
first.
sir,
First
X is
one.
subset of Y.
one.
First option.
First
First
one
option
is
is right.
correct, right? First one is correct because I told you, right? X, when you are saying that X is a proper subset of Y, that simply means X is a subset of Y, okay? But X should not be equals to Y. The equality condition should not hold. Okay, if the equality condition holds, that means it's not a proper subset, but it's a subset, but not the proper subset. Okay, so this is what has been given here also. There is a X and then there is a Y, and when said that X is a proper subset of Y. Okay, for this question itself, is X a subset of Y?
Yes.
Yes.
No, sir.
No, sir, it is a proper
All
subset.
elements are not present.
Yes, it is a subset
Yes,
of Y.
sir. It is a
Subset. Yes,
subset.
sir. It is a
Proper
subset.
Sir, it is a
Yeah.
subset of
But
Y.
not a proper subset.
Both are correct. Okay, it's proper subset or you said subset. Okay, both are correct. The only
So,
condition is if the
sir, it
equality.
means that if a number is a subset, then a equality condition will hold there.
If the number are equal,
Like subset, in subset, the equality condition will hold.
may
but
or
in
may not
proper-
hold, may or may not hold.
Okay, okay.
Okay, but in the proper subset it should not hold. Okay, that's the difference. Okay.
Sir, please give one more example, sir.
Okay, I'll give you one more example. Let's for example again X here, or let's for example I'm writing A 1 2 3 4, B is 1 2 3 4 5. Now you have to tell me, is A a proper subset of B? Sorry, a subset of B?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, it is.
Is A a proper subset of B?
No, sir.
No,
False.
sir. No, sir.
Why
No,
no?
sir. It's false.
Yes, sir.
Because
Yes, sir. It's proper
Yes, sir.
subset.
Yes,
How
sir.
can it be true?
Yes, sir,
Sir,
because
A
It is
is a
not a
proper
large
Yes,
amount
sir.
of A is present
Yes
in
to
B.
both.
Both are correct,
It is a
right?
proper
Both are
subset
correct,
of
sir,
Y.
because all
Both are
elements of
correct,
A is
sir.
present in B. All
Both are
elements of
correct.
A is present
Correct.
in B.
Correct. Both are correct because I told you, right? Now I'll give you one more example. A equals to 1 2 3. B equals to 1 2 3. Now tell me, is A a subset of B?
Yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Correct.
yes, sir.
Equality condition can
Yes,
hold.
sir.
Is
Yes,
A a
And B is
proper
also
subset of
No,
B?
sir.
No,
No,
sir.
no,
No.
sir,
sir.
proper subset.
A
No.
is equal
No,
to
sir. No, sir.
Correct, because the equality should
Yes.
not hold in the proper subset. Okay, but it can
Yes,
hold
sir.
in subset. Okay.
Sir, there is no equality sign in proper subset, and the example you
Yeah,
give is a
correct. He can see that from the sign itself.
equality.
Here it is,
Yes,
the
sir.
equality hold, right? Here, just this.
Sir, proper subset is used when there is no equality. When
Correct.
elements is present. Yes.
Yeah. just the way many of the people write it as a proper subset, or you just have to broad aspect is the subset itself. But if you have to go in deep and then say that whether it's equal or not equal, then generally people use it as a proper subset, just to tell you that those both sets are not equal for sure. Okay, they're a subset but not equal.
Yes, sir.
That's why generally
Yes, sir.
proper subset is used. Okay,
Yes,
making
sir.
sense. Okay, so we'll move to the next
Understand.
one. Yeah. Then something called set comprehension. This is nothing difficult, like just a way to represent. How do you represent set comprehension? How do you generate some sort of a set? Okay, so there is something called, let's for example, I'm just telling you one example. Let's for example, I have to create a set of square of integer or a square of a even integer. Just give me a minute. I'll just somebody at my door. Just give me a minute. Yeah, okay. Am I audible?
Yes, sir.
Okay.
Yes, sir.
Yes.
Yes, sir.
Yes,
Completely audible.
Okay. So I was talking about set comprehension, right? So how do you generally write if you have to create or any set, right? So there was one example that I was telling you. If let's say example, you have to generate a set, okay? That should contain the square of a even number, even integer, only integer, even not, even integer. Then how will you like generate the set? You will generate it like something like you will write it as, what do you need? The square of even integer. Correct? So if you need the square of even integer, x square you need, this is the thing that you need. Okay, this is the transformer. Okay, and then you have to set some condition that x, that you are like x should belongs to what? Which number?
Even integer.
It should be
The-
integer first. Okay, integer. Okay, and then what all condition it should follow? X mod 2 should be equals to 0.
Not 0.
Correct? So
Yeah.
this was the transformer, and this x belongs to G, right? X belongs to G is what? The field.
Generator.
1 second. Okay. Yeah. So this x belongs to Z is what?
Generator.
Is it? Yeah, generator. From where the data are getting generated, and this is the condition that it should satisfy. So that is what? Filtering.
Sir, S mod 2 0. Yes, sir.
Correct? So this is simple.
Yes, sir.
Not will be used anywhere, but I'm just telling you, if you have been asked to write that set belongs to some values and all, you can write it in this form. So there's like, there's just been, I am telling you because it has been discussed in the lecture, so I just wrote it down. Not important, but it should just be knowing. Nobody is going to ask you what is transformer, what
Yes,
is
sir.
generator, and what is.
Filtering was
Okay.
discussed.
Yeah, so they're not important,
Sir,
but
till now, can you please?
What?
Hello. Sir, till now, can you please tell what are important?
Okay, so till now, whatever we have discussed, right? The set theory is important. Okay, set will be asked in the paper. Let's, for example, the cardinality of any set given, or anything regarding subset or the proper subset. Those are important. From now onwards, whatever we are discussing, those are all important. And every year, there will be some 1-2 questions from the relation, the properties of relation. So if you have to just revise one concept from week 1, and then also, like, let's for example, you have a quiz paper of some 50 marks. So almost 12.5 marks will be your from week 1. Okay. Out of the 12.5 marks, right? Like the 25% of the paper, I can tell you out of this 12.5, you'll be having 8 to 9 marks of questions from only from the relation itself. So the properties of relation, you'll be having a lot of conditions will be given to you, and then you'll have to ask, you'll be asked to tell whether this satisfy the first property, the reflexive property or not, symmetric property or not, or a transitive property or not. Okay. So this one, if somebody has not like whatever we have been talking for the last 30-35 minutes, if you not listened, at least now, from now onwards, you can focus it off, and that will give you a much like basically this is the important portion. Okay, the most important portion. for your week 1, the relation part. Okay, the function and all you'll study later also, but the relation is exclusively covered in week 1. So that's why you'll be asked a much more, like out of 3-4 questions that will be asked, almost all the question will be from relation, or maybe one question will be from set or something from function and all, but all the questions will be from relation. Okay, so you'll have to listen or study this part relation very nicely.
Means from week 1, we will get relation question more.
Correct. Okay, so before so in relation is pretty simple. So you will be given 2 different set, right? And then you'll be asked whether A is related to B or not. Okay, how do you find the relations and all? See, there is something called Cartesian product. Okay, so let's, for example, A set has been given to you, B set. Cartesian product is nothing. If you would have read in class 10th and all, there's something called x-axis, right, and y-axis. If you want to write all the coordinates, how do you write the coordinates? Okay, you just cross multiply x and y. So x can have minus infinite to infinite value, y can have minus infinite to infinite value. If you just cross multiply, so cross multiply means if you take one element from x and one element from y, right? So all the coordinate points that you'll be getting, right, those are the coordinate points that you can put it here. Okay, and then I just want to filter it out some values. Let's, for example, x and y are just integers. Okay, so you'll be having some fixed number, right? It will be infinite values only, but at least you'll be having some. So what I'm trying to say is the Cartesian product is almost similar to the Cartesian, that the coordinate system that you read about. Here also the Cartesian product means you have set A and you have set B. A has, let's, for example, 1, 2, 3, 4 as element. Okay, and B also has, let's, for example, 5, 6, 7, 8 as element. And if you have been asked to write the Cartesian product of A cross B, how will you write? The Cartesian product is something like it contains all the ordered pair, okay, where one element is from A and the other element is from B. So the one ordered pair is something like 1, 5. The other ordered pair is something like 2, 5. Similarly, you can just write it as 1, 5, 1, 6, 1, 7, 1, 8. Because what did I say? Ordered pair, okay, where one element, the first element is from A and the second element is from B. Similarly, 2, 5, 2, 6, 2, 7, 2, 8. 3, 5, 3, 6, 3, 7, 3, 8. 4, 5, 4, 6, 4, 7, 4, 8. Okay, so you have altogether how many ordered pair? Can somebody tell me?
The 16.
16 ordered pair. Okay. Right, so that is the Cartesian product of A cross B. So first thing that we have read in relation, or we have just starting of relation, is the Cartesian product. So given 2 sets A and B, all the ordered pair, okay, where one element, the first element of the ordered pair is from set A and the second element is from set B, all the combination that you will be getting. So the set of the Cartesian, so Cartesian product is what? A cross B. You are getting some sort of a set, okay, where you have a ordered pair. Each ordered pair, one is element is from A and the other element is from B. Is it clear? The Cartesian product?
So order don't matter, sir.
Yes, sir.
Order matters here. Okay, the first important part here is order matters in a relation. So as of now, we were talking about the set. In set, the order.
Sir, order here matter.
What?
Sir, why order here
Order here matters because whenever you are writing a Cartesian product, let's, for example, 1, 2, 3, and 4, and here also A, this is A, and this is B. Okay, B has element 2, 3, 4, 5. Okay, when you are writing 1, 2, 1, 2 is not same as 2, 1, because
sir.
You got it right, because 2 is there in A, but 1 is not there in B, right? How can both be same? It's not possible.
No, sir, both are not same. Both are,
Correct.
so here order matter.
So in a relation, order matters a lot. Okay. So I hope that makes some sense. And thanks
Yes,
for
sir.
asking that also. So I was about to
sir.
say, but okay, somebody has asked. Okay, nice, sir. So it should be there in your mind. The order doesn't matter for a set, but it matters for a relation. Whenever you're writing a relation where the order matters, okay, you can't just like switch the values and then order pair and then tell that both are same. Both are not same. Okay, this is done. The Cartesian product is done. And binary relation is nothing but a relation between 2 sets. Okay, so what happens is whenever a relation that you are writing, right, a relation between 2 sets, Let's for example, this is X and Y. So when you are defining a relation, X is related to Y. Okay, what generally, so you have now a Cartesian product of very big number. So here it was A and B was there. I'll just write it as A and B. A was having A and B, 1, 2, 3, right? If you'll just write it A cross B, so you'll be having something like A1, A2, A3, B1, B2, and B3. This is the Cartesian product.
Yes, sir. Understood.
Okay, and then when we talk about the binary relation, a relation between X and Y, that whatever here it has been A and B, is the collection of all the ordered pair containing one element from one set, each set. Okay, in other words, a relation R is a subset. So whenever, so this is the whole chunk of relation that can occur between A and B. Now there will be some relation R1, R2, R3, R4, Rn. Okay, this R1, let's for example have just some chunk, right? A subset of this. Let's for example A1 and A2. So this Cartesian product contains all the relation that can occur between A and B. Okay, now a relation R1 has been given to you, R1 as A1, okay, and then A2. And then you can be asked, okay, is this relation R1 following some property? Let's for example, reflexive, symmetric, or something. So now any two non-empty set has been given to you. The Cartesian product generally has all the relation that can occur between these two sets. Okay, and out of that, when we pick out some value, a subset of that Cartesian product becomes some relation. Okay, some relation R1, some relation R2, something like, and that can follow some properties like reflexive, symmetric, or some, or like three properties that generally we read it out. Is this clear to everybody?
It's very clear, sir.
Yes.
Clear, right?
Yes.
So what I said is,
Sir, I have a doubt.
yeah, tell me.
Sir,
The-
explain one more time, please.
Relation in between more than
Yeah, go ahead.
so can you give an example of a relation between more than two sets?
That is not possible. More than two sets. Either it can be from one set, like itself. It's like, let's for example, it can be in A itself. A, because you can have a cross product of A cross A, right? And then or A cross B, right? So, but Cartesian product you can write it out, but relation, how will you? Yeah. Yeah, go
Excuse me,
ahead.
sir.
Yeah.
Sir, if we are finding like relation between two sets, so binary relation and this Cartesian product will be same, sir.
No, your voice is not audible. So can you just write it out in the chat box?
Yeah.
So till that time, can I ask something?
Yeah.
So like you are writing the Cartesian product or something like that. In that case, the question arises, can the cardinality ask from this, like how many elements are this in this set? It can be asked in the exam or not?
Cartesian product, it will not be asked. These are very simple thing, right? And one
No,
more
no,
thing.
sir.
So yeah, somebody was asking about three set. What was that question? Can you repeat that question?
She was asking if there can be a relation between three sets or more.
See, three set. See, if you are writing, let's for example, A, B, and C, you can write the Cartesian product, okay, between, because you can have a ordered pair in such a way that one element A can be from A belongs to A, B belongs to B, and C belongs to C, capital C. Okay, that the Cartesian product, if you can write it, then there can be a relation also. Okay, but I don't know, have not like came through any, but if you are able to write the Cartesian product, that means you can have a relation between these three also. Okay, I misunderstood that point.
All relations be binary then?
Yeah, all relations are binary. Now the binary relation are something between like two sets, or let's for example, if you have three sets, you can have a Cartesian product and then you can have a relation. Okay. See, binary relation is simply like a relation between any two sets has been given to you. Okay, it's just that the ordered pair that you are writing, right? So the Cartesian product is very big, and out of that you might be having some relation, like a small chunk of that big Cartesian product. Okay, so in
Yes,
simple
sir. There is
language
such
you
a
can just
question
write it
even
as.
in our activity, in our practice assignment.
Okay. So in simple word, if you want to call it as a relation R is a subset of a Cartesian product that you have written X and Y. If you have A, B, C, D, then A, B, A cross B cross C cross D, something like that.
Sir, if there is 2 point mentioned in a Cartesian plane and 2 point are joined by a one line, at the 2 point between 2 points, there are many points in the line. So are these points are subsets?
This point subset of like, see, subset I taught you, right? I taught you there are some big set, and out of that big set, if you are, let's say example, you have a set that contains 10 element, and out of that 10 element, if you have another set that contains 5 element, that 5 element is there. So let's for example, X has a 5 element and Y has a 10 element, and X, all the elements of X are there in the element of Y, then you can say that X is a subset of Y. That is
So
what I'm saying.
how can we visualize this in Cartesian plane between 2 points? If can you show?
No, there's nothing to be shown, right? See, it's pretty not that difficult to understand. What I'm trying to say is, you have something like a point, something like 1, 2.
So I understand this. I understood this. But I want to understand in Cartesian plane, how to see that in Cartesian plane.
What you want to see?
This the product of two
No, that
sets.
example that I gave you just to make you understand that this is how the Cartesian product works. Okay, there is nothing related to that coordinate geometry.
Okay.
Okay, yeah. So that geometry point that the example I gave you to make you understand that the point that we generally consider, that you can just think of as some sort of, because they're also in the coordinate plane, X and Y are there, and every point you can just think of some sort of a Cartesian product. Okay, if X has an element from minus infinite to infinite and the Y has an element from minus infinite to infinite, so every point that you get, right, coordinate point that you get in the form of X and Y can be a Cartesian product, okay, where X has all the element and Y has the element from minus infinite to infinite.
Yeah, I think when we move forward to functions, you will see that every function is a relation.
Correct.
And line has a relationship. Parabola has a parabola function.
Correct.
Line can be drawn. And set of points that lie on a line form a relation, which is a subset of the Cartesian product, which is your entire plane. I think when we move to functions, you will understand it better.
Yeah. Okay. So I hope this is clear. Let's move to the properties of the relation. So we have talked about the relation. Now we'll talk about some of the very important properties of a relation. So the first important property is the reflexive relation. Okay. The definition is pretty simple to understand for the reflexive relation. So reflexive relation is something like, let's for example, I was talking about a Cartesian product, right? A big set, right? From there only we are picking out some relation, and then we are talking about whether this R1 satisfy the condition of a reflexive relation or not. Correct? So what is the condition to make a relation a reflexive relation? So the condition is, let's for example, let R be a binary relation on S. S is a some set. Okay. So to make this, and then from this set, R has been taken out, and R is some sort of a relation, and you have been asked whether R is a reflexive relation or not. So to make this R a reflexive relation, this can only be done if and only if for all the element that is present in X, let's for example, A has element of 1, 2, 3, 4. Correct? And you can have a Cartesian product of S cross X itself. So you have S 1, 2, 3, 4. 1, 2, 3, 4. So you'll be having a Cartesian product of S as S cross S. Okay, you'll be having 16 values, right, in that Cartesian product. Now, a relation R has been taken out, and then you have been asked, tell me whether this R is a reflexive relation or not. How will you check that? For this R, okay, this can be a reflexive relation one and only condition if this R has all the element, whatever the element was there, okay, for each of the element, wherever X was belonging to S, X comma X should be present. It should be there in R. Let's, for example, 1, 2, 3, 4, 1, 2, 3, 4 is there. Now I'm taking R relation where it has been written 1 comma 1 and 2 comma 2. Okay, and then you have been asked whether this is reflexive or not. The first thing that you have to check is the one condition I told you, right? For all X belongs to S. What are the all X that belongs to S? 1, 2, 3, 4. Correct? For each of the 1, 2, 3, 4, all 1, 1, 2, 2, 3, 3, and 4, 4 should be present in R. Then only that relation will become a reflexive relation. Okay, but for this condition, only 1, 1, and 2, 2 is present. 3, 3, and 4, 4 is not present, right? So see, that's why this will not be a reflexive relation. Is it making sense or not? Okay, I'll reiterate it again, what I'm trying to say. See, if you'll just read this definition that has been written here, R is said to be a reflexive if and only if for all X is you can just think of as X as an element, each element present in the bigger set S, where you have to tell whether relation exists or not. Okay, so in this bigger set S, okay, all the element of S, the capital S, okay, if for all X belongs to S, XX should be present in R. R is a relation where you have to tell whether this is a reflexive relation or not. Okay, so for each of the element 1, 1, 2, 2, 3, 3, 4, 4, if that is present, you can tell that this is a reflexive relation. Apart from that, 1, 1, 2, 2, 3, 3, 4, 4, apart from that, any other elements are there, doesn't worry us. Okay, this will be a reflexive relation. The only condition is for all X belongs to S, XX should be present in R. Is this making sense or not? No.
Sir,
Are
the
you able to
doublet
Sir,
should
I
be
have one
present
doubt.
of every element.
What?
Doublet of every element should be there.
Doublet of every element should be there in that
Sir,
relation.
I have
If
one
that
doubt.
is satisfying, then you can say that. Okay, and now first
Yes, sir.
the first example. Okay, so you were having S, yeah, S is 1, 2, 3, 4. So you'll be having some S cross S, right? Now you have been asked to tell whether this R1 is a reflexive relation or not. See, this R1 is a reflexive relation. What are the things that you have to check? For each of the element that are present in S, right? How many elements are there? 1, 2, 3, 4. So minimum 4 elements should be there in R1 also. Which are the 4 elements? 1, 1, 2, 2, 3, 3, 4, 4. If all those elements are there, apart from that, anything else I don't have to worry about. So here if you'll see 1, 1 is there, 2, 2 is there, 3, 3 is there, 4, 4 is there. That makes this relation R1 reflexive. Second case, 1, 1 is there, 2, 2 is there, 3, 3 is not there. So even though you have 2, 3, 4, 4, 3, 4, doesn't matter to us. The most important thing was for all element in S, right? The doublet should be present, right? So XX should be present. XX should belongs
Means,
to.
sir,
In the third
for
condition,
all
just give me an
elements,
example. Just let me give you some example, right? So 1, 1, 2, 2, 3, 3, and 4, 4 is present. That makes the system reflexive. Apart from that, 2, 4, 4, 1 doesn't matter. Anything else is present, that should not matter us. That will be a reflexive relation. Okay. So for every element of X, like element of S, okay, the doublet should be present in that relation. Okay. If that is present, you can say that that's a reflexive relation.
Okay, so like the thing not matter, like we are writing the 2 2 first, 1 1 later. The thing is the doublet should occur in the thing.
Correct. Let's, for example, this is R5. R5 is 4, 4, 3, 3, 2, 2, 1, 1, 1, 2, 2, 3. Is this a reflexive relation?
Yes, sir.
Yes.
yes, sir, it is a reflexive relation, sir, because it has include all elements of XX
Correct.
regarding X, Y, and YX.
Yeah. Anybody
If I am
any
right.
confusion here?
No,
No.
sir, I have one doubt.
It's clear now.
Yeah.
Sir, what's the difference between identity relation and reflexive relation?
See, identity, it should just have this 4 element. Okay. Anything else will make that relation not non-identity. Okay. But for reflexive relation, apart from these 4, anything else also can be there. Okay.
So, sir, in
Okay.
identity relation, there will be no more than 4 elements, na?
Correct. Yeah.
And in the reflexive relation, there can be infinite.
Correct.
But
Infinite,
the
not
condition should be
infinite,
set.
because you don't have infinite element in the bigger like Cartesian
Sorry.
product itself, right?
This is sorry, sir, for saying infinite because but it must to be satisfied only it has element present all elements of x, whatever it the elements
The identity
x,
should be
comma x.
having the number of element that was, so let's for example, S was A, B, C, D, E. Okay, so the identity will be AA, BB, CC, DD, and EE. This is identity, but reflexive can have this plus something else also, AB, BC, something like that. Okay.
Okay,
Is it
Yes,
clear?
understand.
sir. Yes, sir. Thank you.
Thanks.
Got it, sir.
Excuse me, sir.
Yeah.
Sir, the syllabus covered here is same as the syllabus in recorded sessions in week 1, like that?
Yeah, more or less same.
Okay. Sir, it will be helpful in the meetings if it is clearly mentioned it is a class or doubt clearance session, sir.
Okay, it will be mentioned from next session.
Yeah. Sir, also where can we find the recording of these live sessions, sir?
It is there on the portal, like not on the portal, it's there on the, if you will go to the YouTube, there in the YouTube, IITM BS has a channel. In that channel, there might be some sessions for Maths 1. So there you
Yes,
can
sir,
find
it's live right now there.
Yeah, sorry to mention, sir. Actually,
Yes, sir. It is also running on YouTube, guys.
Yeah.
Yes, sir. Actually, sorry to mention, for daily we are having live sessions, and if we go to the YouTube channel, it is getting difficult to see, sir, exactly which is the session. Like
Yeah, I will name it
today's.
out. So yeah, today's session was not named. It will be named. All the session will be named. Okay.
Not only for this course, sir, for every
For
course.
other
Like,
courses, you can talk to the instructor. I'll inform them, but I can't guarantee for them.
Sir,
I'll make sure that for my courses, it will be mentioned.
sir, one issue is that, sir, when I open CT calendar, it is showing math.
Thank you for your support, sir. Actually, the same issue for every course is like
No,
when we
for
go to the
Maths 1, it
YouTube.
will not happen. For Maths 1, I'll make sure, because
But sir,
every
the
time
calendar is not working well.
what calendar is not working well? Okay, I'll check with the team what is the issue, the operational issue. Okay. But
My
for
issue is that, sir,
regarding naming, I'll make sure from next session.
when sometimes I open CT calendar and click their meeting schedule, so it open math.
Yeah, just one kind request from us is like today's session. This is a session. So this is a recording for so and so session, and PPT or PDF material. If we find all things at one place
See, the
without any
PPT I will attach in the calendar also, from there
Sure,
also.
sure,
The
sir.
people, yeah, so that will make
Yes.
every time
Actually,
you do that, after the session, it will be attached.
Yeah,
So
actually,
the-
yes.
Yeah.
Sorry to interrupt, sir. Actually, recordings materials are scattered here and there. It's getting very difficult for us to easily find out this is a session, this is the material for that session.
No, so for Maths 1, it will be there in the calendar itself, the YouTube link and the drive link of the PDF. Okay. For the other courses also, I'll talk to their team member. If they will do it, that well and good.
Yes.
So the two things. One thing, the calendar updation will keep on happening after the session itself regarding the YouTube link and this the PPT and the session name. Okay, the session name, because this was the first session, it was not named it was just named as an instructor, just to tell you that this is the first instructor session. From now onwards, every week you'll be having 3 sessions. First session, it will be written week 1 summary session, week 2 summary session, week 1 doubt session will be the second session, The third session is problem solving session. So it will be mentioned week 1 problem solving. So I don't think so you'll be having any doubt. Okay, there.
Thank you so much, sir. Thank you for your support. One last request, sir. Actually, that's just one last request, sir. Actually, multiple people are facing different issues. That support number is not working in discussion forum. If we mention, no one is replying, and the support mail is also no response, sir.
Maybe today they might be on a leave, Saturday, Sunday. So maybe from Monday you'll receive the.
No, sir, on a working day in working hours also. And the website also, like, sir, so many issues. Actually, when we see latest, they mention latest updates. But when we go to the section, that section, the information is about 2024 batch. So everywhere there's so much ambiguity.
Man,
sir.
let him teach, right?
Yeah. So sorry, sir, I disturb. Actually, I don't know where to mention the problems. So just there's no point of contact. So just mentioning things. Please forward the things to concerned authorities. So actually, daily we are facing one or the other issue. Just thought to mention that. That's it.
Sorry for that. Okay. Okay, can you take this all doubts in the end? I'll wait after
Sir,
10.
hello, sir. I have one suggestion. The
I'll wait.
non-academic
Yeah,
doubts should be in the last.
yeah. Okay, yeah. Thanks for the suggestion, Sayan, right? Yeah, in the after 10, I'll wait, okay, for your doubts, whatever doubts that you have it. I can wait for half an hour or 45 minutes for a non-academic or academic, whatever doubts there. Okay. Okay, let me finish it off by 10 and then I can take your doubts, huh? Okay. Thanks. So what I was reflexive relation is clear, right? Everybody?
Yes, sir.
Okay.
Yes, sir.
Yes, sir. Clear. Yes, sir.
Yes, sir.
Thanks. The next part is the symmetric relation. Okay, the next property of a relation is the symmetric relation. Here, whenever you have been given some sort of a relation and been asked whether it's a symmetric relation or not, what you have to check is, so for any set, let's for example R is the set, is said to be symmetric if and only if for every element belongs to, that is in the X, every element that is XY that is belongs to R, YX should be there. Okay, the reverse of that should be there in R. Okay, so here there is no condition on S, the bigger set. Here the condition is on R itself, where for which relation you have to tell about whether it's a symmetric or not. Let's for example, there's a relation. Okay, here it has been given R1. It has been given 1 2 2 1 3 4 4 3 and 2 2. What is the condition? For every xy means this you can consider it as a xy. So xy is x equals to 1, y equals to 2. So for every xy, yx should be present. For every xy, yx should be present. Now start scanning it from here. So this is xy for me. 1 2 is xy. What is the yx? 2 1. So 2 1 is present. Correct? Now for 2 1, 1 2 is present. For 3 4, 4 3 is present. For 4 3, 3 4 is present. What about 2 2? For 2 2, 2 2 is also present, right?
Yes,
So
sir.
that means this is a symmetric relation. Is it clear? So every time you
Yes,
have to
sir.
say the same thing.
Yeah.
Whatever relation has been given to you R, correct? Any combination 1 2 2 1 3 4. Is this a symmetric relation?
No, sir.
No, sir.
No, because why this is not a symmetric relation?
Sir,
No,
it is
sir.
not
Sir, because for 3 4 there is no YX.
Yeah, this here
what we are.
for this combination of xy 3 4, yx is not present.
There is no YX.
Correct. Nice. Okay. So I hope this is clear for symmetric
Yes.
relation. Okay. So
Yeah.
reflective was the one
Yes, sir.
where all the duplets should be present. Okay. For a bigger set. Let's for example, S was having 1, 2, 3, 4. So 1, 1, 2, 2, 3, 3, 4, 4 is present. If only those are present, you can call it as identity or reflexive, whatever you want to call it as. But apart from those, if there is something else also present, 1, 1, 2, 2, 3, 3, 4, 4, and then 1, 2, 3, 4, 4, 5 present, those are reflexive because the bare minimum condition of the reflexive relation is satisfied. So that's a reflexive relation. For symmetric relation, there is a condition on R itself for which you have been asked to tell whether this relation is a symmetric or not. So you have been asked R1 is reflexive, symmetric or not. You have to check in R1 itself. Okay, for every xy, yx should be present. What is the case for R2? For 1, 2, 2, 3 is present. Oh, sorry. For 1, 2, 2, 1 is present. Yeah. For 1, 2,
Yes, sir.
present, right? For
It
2,
is
3, 3, 2 is present. For 4,
3 2
3,
is
4
present.
is present. Correct.
3 4 is
What
present.
about this
Sir, this is
condition?
The
Sir,
4-3 is
there
not
is no 4 3.
4-3
no,
not
sir, this is
present.
not
4 3.
symmetric.
Yeah, this is
No,
present.
4-3 is not present.
4, 3 is not
Sir,
present.
because for x3 and y4
3
is
4
it
is
is
not
not
there.
present. Y4 is x
Okay.
4-3 is
Nice.
not present.
Sir,
Yeah.
sir, for the given set S, if only 1, 2 and 2, 1 is present, then is it a problem?
No problem. That is also a symmetric relation. That is what I told you. There is no condition on S. Okay. There is no condition on the bigger set. There is just a condition on R. So here, if you read it, R is said to be symmetric if and only for every xy belongs to R, yx should belongs to R. Okay. But if you read it here, for a reflexive, there was a condition on S also. For all x belongs to x, xs should be present in R. Okay, I hope there is a clarity, the clarity should be there, right? Here, all the values, only one will not make the system, this relation reflexive. Okay, all four should be present because it has been said for all x belongs to x, s, xx should be present. But here, there is no condition as such like for all the mirror image of one, all the values should be present. Here it has been given that if xy is present, yx should be present in R. So if, let's for example, RR has just 1, 1, is this a symmetric relation?
Yes, sir.
It's a symmetric
Yes,
relation.
sir.
Correct.
Yes,
It's
sir.
a symmetric relation because for 1, 1, 1, 1 is present. That's it.
Yes, sir.
I don't have to
Yes, sir,
think
because
about how many elements are there in S, the Cartesian product. I don't have to think about those things. I just have to look into R itself. If R for all element in R, x for all xy, yx is present, that means this becomes a symmetric relation. Now one more example. This is R4. 1, 1, 2, 2, 3, 3, 4, 4, 4, 5. Now tell me, is this a reflexive?
Yes, sir.
Yes,
Yes,
reflexive.
sir.
Is this a symmetric?
Yes, sir.
No.
No, sir. No, sir.
No, sir.
No, sir.
Why it is not a
Oh,
symmetric?
no, sir.
For
it
4,
is
Because
not
no.
symmetric.
I4
It's
and
not symmetric
For
because
five
for
is
3-3,
It's
because for
not
4,
symmetric
5,
because
5, 4 is
5,
not
4 is
present.
not present.
4 3 is not
5, 4
present.
is not
5,
Yes,
4 is
sir.
because
not.
for 4, 5, 5, 4 is not present. So it is not
5,
symmetric.
4 is not present, sir.
Now tell me, this relation is reflexive?
No, sir.
Yes, sir, it is reflexive.
Yes,
No,
sir.
sir.
Yes, sir,
yes,
yes,
sir.
sir,
This
it
is
is
a
reflexive.
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 Is this a
No,
reflexive
sir.
relation?
It is not reflexive.
No.
Yes,
Yes,
4
sir,
no,
it is.
4 is not represent.
Okay,
Sir, it
I
is
just want to.
reflexive.
This
Symmetric.
is okay.
4
Okay.
is not
This is
there.
not a reflexive relation because 4, 4 is not present. S contains 1, 2, 3, 4. So for
So,
all
sir, yes, sir.
element in X, all element in
It is not
S,
reflexive because
X should
4,
be
4 is
present.
not present.
Correct.
4,
4,
4
4
is
is
not
not
present.
present. Is this
That F,
symmetric?
Yes.
Yes, sir.
yes, sir.
It's
Yeah.
This is
symmetric.
It's
symmetric.
symmetric because for
Yeah,
1, 1, 1
symmetric
is
is
present,
there.
1, 1
Yes,
is
sir. It
present,
is
2, 2,
Yes,
for
sir.
2, 2, 2, 2 is present,
This is not
it is present.
Nice. Okay. I hope this is clear to everybody. The difference between
Sir,
reflexive
it
and
is very
symmetric.
clear.
Sir,
Yes.
the identity relation also can be symmetric relation.
Correct. So the next statement is all the identity relation. Are all the identity relation symmetric?
Yes, sir.
Yes, sir.
Are all symmetric relation identity?
No, sir.
No, sir. No, No, sir.
No,
No,
sir.
sir.
Correct. Nice. Okay, let's move
Sir,
to the.
sir,
Yeah.
I have one doubt. Sir, I want to ask that you said all identity relations are symmetric, but all symmetric relations are not identity. So, sir, please explain me this statement with example. Can you please, sir? So I have some little bit of confusion.
What is the identity relation here? Can you just write it down for this S?
Sir, identity relation 1, 1,
Tell me.
2, 2,
2, 2,
3, 3,
3, 3.
4. Sir, sorry, sir, I don't
What?
understand identity. I am little bit get again confused between
4,
identity.
4. Okay, this is identity relation, right? Now I have to write one symmetric relation. Is 1-1 a symmetric relation?
Yes, sir.
Okay, so 1-1 is symmetric. Is 1-1 identity relation?
Yes, sir.
How 1-1 is an identity relation? I'm just talking about for
No,
A.
sir.
It can be identity if the element S was having only one element, 1. Are you getting me or not?
Yes,
Yes, sir.
yes, sir.
Yes, sir.
Yeah. Okay, I hope this makes it clear. Let's move to the next part, transitive relation now.
Sir, before you move to the next part, one more question was there.
Hmm.
Initially, you said in the reflexive it is 1-1, 2-2, 3-3, 4-4, and in the end you also added 1-5 or 4-5, I believe you added. But 5 is not in the given set, so how it can be a reflexive?
Okay, yeah, correct. That was incorrect. That I wrote was incorrect. Yeah, 5 can't be there.
Okay.
Yeah,
Sir,
only
one more doubt.
element from the
Yes,
Cartesian
sir.
product
Identity.
can come.
Sir, identity relation only include 4 elements. 1, 1, 2, 2, 3, 3, 4, 4. No.
What?
Sir, identity relation includes 4. You tell that only 4 elements. 1, 1, 2, 3, 3, 4.
No, your voice is not clear. I can't hear you.
Sir, I am saying that identity relation only includes 4 elements. 1, 1, 2, 2, 3, 3, and 4, 4.
Not 4. That depends on this set.
Okay. Means
Where
if
from where
only
the Cartesian product has been made, right? On that set it depends. Okay.
means it only includes 4 elements. No?
If you have 4 element here, yeah, the identity should be having 4. All the elements 1, 1, 2, 2, 3, 3, 4, 4, all should be there. Okay.
So suppose it is 3, 2, 3, 5 then.
Then you should be having 5 element.
Oh, thank you, sir.
But identity relation, I don't think so. It has been taught. Okay.
Okay.
If it is taught, okay, it's fine.
Excuse me, sir. I have a doubt.
Yeah, see, I want to clarify again one thing. See, if you have been given, let's for example, A equals to 1 only. Then if you are writing a relation R1, 1, 1, this is identity, correct. But if your element is 1, 2, 3, and then if you are writing R1 as 1, 1, this is not an identity relation. Okay, I hope this is clear. For identity relation, all it should include all A, like AA for every element of A. Okay, not only some partial elements and all. Can we move to the next part?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Excuse me, sir. I have a doubt.
Okay, yeah, what's your doubt?
Sir, can you take this example?
Okay.
1, 2, 2, 1,
1,
4, 8.
1 second. 1, 2,
2, 1,
2, 1,
4, 8,
4, 8.
8, 4,
Hmm.
8, 5,
Yes.
4, 2.
What you are asking?
Is it symmetric or not? I am confused a little bit.
How this is symmetric? For symmetric, what did I say? For 8, 5 is 5, 8 available. For 4, 2 is 4, 2, 4 available.
No, again, if we take 4, 8 and 8, 5.
Yeah, if you will take 5, 8 and 2, 4, then it is symmetric.
It is not symmetric.
Okay,
What?
okay, I got it.
You got it right. Okay, let's move to the next part. Okay, some examples are there that you can just read it when you will be getting the slide. Now the most important one is the transitive element. Transitive is you have to understand it very carefully. So the transitive relation is something, let's for example, let A be a set and you are making a relation on A. Okay, so a relation R is a transitive relation if and only if. For AB, if AB belongs to R and BC belongs to R, then AC should be there in R. So what I said, if AB belongs to R, BC belongs to R, AC should be there in R. Okay. Then you can say that is a transitive relation. With example, you'll be able to understand it. This is a set S. Now I'm asking a set R1, 1, 2, 2, 3, and 1, 3. Is R1 a transitive relation?
Yes, sir.
The same sentence.
Yes, sir.
Yes, it is transitive.
Yes, sir, it is transitive.
Yes.
Yes, sir.
Yeah. Correct or incorrect?
Correct.
Yes, sir.
Correct,
Correct,
sir.
sir.
How did you check?
Transitive.
How did you check? This becomes AB. Okay. For AB, you have to start scanning for this AB. Is there any element that starts with B? B means 2 here. So yeah, this element. So this becomes BC. Now what you have to check? If AB and BC is there, AC should be there. Is AC there? Yes. That means what?
Yes, sir, it
Yes,
is
sir.
there.
This is one element, one scanning, one iteration you have done. Now go to the second iteration. Now for 2, 3, is there any element that starts with 3? That also you have to check, right? You can't just stop it here. You have to check for each and every AB for BC. If AB, BC is present, AC should be present. Are you getting me?
Yes, sir.
Yes, sir, get.
Now, correct. So now for 2, 3, is there any element that starts with 3? Because why I'm
No,
saying,
sir.
why can somebody tell me why do I want any element that starts with 3? Because
To
I told you,
fulfill
right, correct. For AB, I have to search. First thing I have to search is there any element that starts with B? If there is any element, then I'll mark it as BC, and then AC should be present. Okay. So for 1, 3, I for 1, 3, 2, 3 was there, and 1, 3 was available. Fine. For 2, 3, is there any element that starts with 3?
No, sir.
No, sir.
No. So I don't have to go next. Okay, because for AB, BC is not even present, right? If BC is not present, then no need to check anything. Now for 1, 3, is there any element that starts with 3?
No.
No, sir.
Now that means
No, sir.
all the scanning, all the iteration for scanning is done. Now you can directly say that this is a transitive relation. Okay, is this clear to you guys?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now the same question. R1, 1, 2. Is this a transitive relation?
No.
Yes, sir.
Think what I said in the last question, what I did.
Yes, sir,
Just
it
think.
is transitive.
Transitive.
Yes, sir, because B2C is not present, so automatically it will be.
Correct.
So,
Very nice. Yeah.
Yes, sir.
Nice. Yeah. So that is what I was trying to say. Here, AB is there. Is any other element that starts with 2? No.
No, sir.
I don't have to
No,
check.
sir.
So I don't
No,
have to
sir.
check anything. This is a transitive.
Yes, sir. Yes.
Okay. You got it?
Yes,
Any
sir.
confusion anybody has? No, right?
Sir, just
No,
one
sir.
thing I wanted to ask.
Yeah.
If we have A to AB and BC, so we should have AC or CA will also work.
No, CA will not work. I told you
Okay.
in relation order matters a lot.
Okay, sir.
Okay.
Okay.
Now the relation R1, R2, R3. Just go through R1, R2, R3. All 3 are transitive. Think about that. I'm just giving you 2 minutes of time to think for each of the relation R1, R2, R3. Just R1, R2, R3. Any doubt in this R1, R2, R3?
Sir, if
No, sir.
if
Sir, I
there
have
is
one doubt.
only one,
1,4.
One by one. Yeah.
R2, sir.
R2.
How R2 is? Yes, sir. How
Why,
R2 is
what's
transitive?
the doubt in R2? R2 is transitive, right? I told you, right? For AB, if you're not able to find any BC, then you can directly say that that's a transitive, right? That is what I told you, right? R2 is what? R2 is 1,
1,
4. Is there any element that starts with 4?
No, sir.
No. That means what? It's a transitive. You don't have to go and check for any other element.
Sir, R3. Can you explain R3?
R3. Okay.
Yes.
So for R3, what are the elements? R3 has 1, 3 and 1, 4. Now for 1, 3, is there any element that starts with 3?
No, sir. Nope.
No, sir.
Is there any element for 1, 4 that starts with 4?
No, sir. Nope.
No, sir.
Why I'm
No,
asking?
sir.
Because see, this becomes AB. I have to search for any element that is in the form of BC. That
sir.
means any element that starts with 3. No. Here also again I'll mark it as AB. Is there any element that starts with 4? No. If it does
No,
not, then I
sir.
have to
No,
search.
sir.
I don't have to search
No,
for
sir.
any
Not
BC
at all.
and all. Okay.
Okay, sir. Okay.
Clear?
Okay, sir. Yes, sir.
Sir, please.
Yes,
What
sir.
about R4? Can you
Yeah,
just
I
think
have a
about
one down.
R4?
R1 1, 2, comma 2, 3 is there. How it is transitive?
So, okay. So this is A, this is B. Is there any element that starts with 2?
No.
No, it's
Yes,
there,
yes,
right?
sir.
This
2, 3.
element starts with 2, right?
Yeah.
So this
2, comma
becomes
3.
BC. Now, is
Okay.
AC present?
Yes, sir.
AC is present, right? This is A and this is C, because A was 1 and C is 3.
Okay.
Present. Now check for 2, 3. Is there any element that starts with 3?
No, sir.
No,
Is there any element that starts with, yeah, for 1, 3 again, is there any element that starts with 3? No.
no,
So you
sir.
don't have
No,
to
sir.
think of
No.
it. Correct? So this becomes correct. Okay?
Okay, I understand.
You got
Sir,
it.
R5. Tell me about R5.
What? R5? Yeah.
Sir,
Think of R5.
R5.
Think of R5. What is R5? 1, 2, 2, 1. If this is AB, BC, okay, then 1, 1 is present. Correct?
Yes.
Now think of 2, 1. For 2, 1, is there any element that starts with 1? Yeah, 1. That means what?
Yes, sir, it is.
This becomes AB and this becomes BC. So now I need AC. What is AC? 2, 1. 2, 1 is present. Correct. Now 1, 1. Is there any element that starts with 1?
Yes.
Starts, right?
Yes,
This
sir.
is 1, 1 and 1, 2. What I need? This is AB, this is BC. So I need AC. 1, 2. 1, 2 is present? Present. Now I'll come here. 2, 3. Is there any element that starts with 3?
No, sir.
No.
No,
No,
right?
sir.
Okay.
So it
Correct.
should be transitive.
It should
But
be.
there is no element 1, 3.
Why do you need a, okay, yeah, one, correct, 1 second. Why do you need 1, yeah, 2, 3, is there any element? No. Why do you need
1,
Yeah,
1,
1, 2, 2, 3.
3, then 1, 3.
Then we need
What?
1, 3. We need 1, 3 also, right?
Yeah, you need 1, 3, correct. Nice observation. Here it is AB. Is there any, what are the element that starts with 2? So this was the one element done. For this, we were having 1, 1. But for what about this BC? Okay, this AB, right? This also starts with 2. So now what I need, 1, 2 is there, 2, 3 is there. I need 3, 1, 1, 3, right? This becomes AB for us, this becomes BC, and this becomes AC. So 1, 3 should be present, right? 1, 3 is not present. That's why this is not a transitive. Clear?
Got it. Got it.
Yeah,
Sir,
clear.
in relation R4, 2, 4, for 2, 4, 4, 2 is not present. Then why would we need 2, 2?
What?
In R4, 2, 4 is present, but 4, 2 is not present. So why would we need 2, 2? For the reason is
2,
given.
4, 4, 2 is symmetric. It's not transitive.
Then also, why 2, 2 will be needed?
Okay, leave apart the reasoning. At least leave apart the reasoning. At
I
least
think
tell
2,
me
1.
whether R4 is transitive or not.
No, actually, there is 2, 1 and 1, 2, which means 2, 2 also should be there.
Correct. Yeah. So if you have 2,
2, 1, which is the last item. 1, 2,
yeah.
which is the
Yes, sir,
second.
got it, got it.
2, 1 and 1, 2. Yeah. So that is what in transitive you have to scan it very carefully. Okay. Like you have to go with each of the iteration very carefully. Then only if the number of element is less, then you are safe. Okay. You can directly tell whether it's a transitive or not. As the number increases, you'll have to check each and every element very nicely. Okay.
I was going only from left to right.
No, you have to take right, left, everything, not only left to right. Okay.
Thank you, sir.
Thanks. So this relation is done. There are some example it has been written. You can just read it out for if you are not able to understand it, maybe in the next session we'll discuss. But yeah, there are some real life example has been given whether the parallel lines are transitive or not. Are the parallel lines transitive?
No, sir.
Yes.
Why not
Yes,
transitive?
sir.
L1 is
If
parallel to
lines-
L2, L2 is parallel to L3, right? L1 will be parallel to L3 for sure.
Yes, sir. Yes, sir. It is transitive.
And then you have a equivalence relation. If something follows all three, those are the equivalence relation. Okay, simple. I'll not be discussing much about that. So till now, the relation is the most important portion. You should be knowing each and everything about the relation. Okay, all the three properties. If you're not aware of the identity, even I am not sure whether if identity has been discussed, you can learn identity also, but these three are very important: reflexive, symmetric, and transitive. Now let's deal with some sort of a function. Okay, so function is you can just think of as a subset of a relation itself. Okay, so when you were writing the Cartesian product, right, you were having a large set, right? Out of the large set, you have some sort of a relation. So you can just pick it out some like ordered pair, and then you say it as this is a relation, R1 relation. See, and R1, and that you can have n number of relation, and that also follows some of the properties. But out of those relations, some can be function also. Okay, and which are all those relations which are function? Where if you are mapping from X set S X to set Y, one element, so the one input should not give you two output. So those type of relation are functions. Okay, so here it has been written here very nicely. A function is a relation in which each element in X set is mapped just to a unique element, not unique one element in Y. So there's a difference between unique element and a one element. So here I'm saying it's not unique element, it's just one element. So whenever, let's for example, how do you write a function? You write it function as a fx, right? Equals to y. So when you put some x value, you should not be getting 2y. That can't be a function, right? Let's for example, you are putting f of a. You can't get 5 and you can't get 6 all together. That's not possible, right? If you are if you have a function, if you put some input, right, from a domain, you should be getting only one output. It can't be two output at a time. So if you are getting two output at a time, that means it's not a function. Is it clear? So function is nothing but a subset of relation. But whenever you're putting the input values, you're putting in a relation, you should be getting just one output. And if you have a plot, so you can pretty very easily check that whether it's the graph or the plot graph is function or not. So you can see that in the second plot, right, the graph 2, this is not a function because at x1, whenever you're putting x1 in this function, you are getting two output, y1 and y2. You don't know which one will be the final output, right? So if you don't know the final output, you can't say this is a function. But in the first graph, you can see that at fx1, the output is clear, y1. Even though at some value, let's for example here at x2, the value will be y2 only. That is not a problem. That is what I said. It should not be unique. It should be just one element, one input, one output. Okay, nothing. I'm not talking about uniqueness and all. It's just that if I'm putting one input, the output should not be more than one. The output should be only one. Okay, you can check it with there is something called vertical line test. So if you have been given a plot of a graph and then you have been asked whether this is a function or not, what you can do is drop a line, vertical line. If that line cuts more than one times the function, one times the graph, then this is not a function. So you can see that here. I am dropping a vertical line. It is cutting at two places. That means at one point there you are getting two values. So that means what? This is not a function. Okay, but for this case, if I'll drop it, you can see that at every input you have one output. So that means it's a function. Is it clear, the function stuff?
Yes, sir.
Yes.
Yeah.
Clear? So function has, let's for example, that's not mentioned. The function has some 2-3 things. Okay, there is something called domain of a function. There is something called codomain of a function, and then there's something called range of a function. Okay, I'll just write it down here. It has been not mentioned here. So okay.
I think it's there in one of the slides.
Okay, about the
So
range.
the graph one is many to one, right?
Yeah.
Okay. One sec. Okay, yeah. What you were saying?
Yeah, domain,
The
codomain, and range.
above graph one, it is many to one, right?
Many to one. Yeah, you can say that it's a many to one. The first graph, right?
Yes, sir.
Yeah, you can say that. But we have not talked about those things, and you have not like you are supposed to learn, but not now. Week 5 and all, you'll be asked to learn about those things. Yeah, it has been written here, domain and function, everything has been mentioned here. So function generally has three things, okay? There's something called domain of a function, there's something called range of a function, there's something called codomain of a function. I'll just plot it and that will make more clear. So let's, for example, there is something called set x has been given to you 1, 2, 3, 4, and then y has been given to you a, b, c, d. Let's, for example, if you are putting a equals to 1, you are getting b as output. If you are putting 2, you are getting c as output. If you are putting 3, you are getting d as output. And if you are putting 4, then you are getting c as output. Now tell me, is this a function or not?
Yes, function.
Yes, sir.
Is it a
Yes,
function?
It is
sir.
a function.
No, sir, no,
Yes,
sir.
sir.
No, sir.
Okay. Why this is not a
It is
function?
it is
Sir,
a
because
function.
C mapped to two
No,
values,
that's
Sir,
okay.
C is mapping 2 and 4. That's why.
Okay.
2 and 4.
To avoid this confusion, only I
It is
wrote
a
this. Okay.
function. It is a
So it's
function.
function.
It
It's
is
a
a function only.
It is a function, sir.
Okay. Thanks,
All
whoever
x is
understood it.
mapped
But I'll
to
just
what?
clarify whoever has a doubt. Okay, I'll clarify. Everyone, most of you have understood, but somebody who has not understood, I'll just clarify. What I said in the starting, for any input, you should be having one output, correct?
Yes, sir.
Yes,
Okay.
sir.
I didn't told unique output. I just said one input, one output. I didn't say unique output. Okay, every input should have a unique output. If I would have said unique output, then it might not have been a function. But what I said for F1, if I'll put F1, what output I should be getting?
B.
B.
If I'll put F2,
B,
what
sir.
output I should be getting?
C.
C, sir.
C.
If I'll put F of 3,
D.
Say
D,
D.
sir.
F of 4,
D.
C.
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 C, sir.
at any position did you felt if I'll put input, I'll get 2 output? Was there any
No,
condition
sir.
where I could no, right?
No,
No,
sir.
sir.
No.
If
No, sir.
that condition is
No,
not
sir.
there, then you can directly say that this is a function.
Got
Yes.
it. Got it, sir.
Okay, let's, for example,
Clear,
I'll
sir.
just give you one more example. Let's if this was the case, 1, 2, 3, 4, A, B, C, D. So 1 was here. Now, is this a function?
No,
No.
sir.
No, sir.
No, sir.
No,
It's
sir.
not a
No.
function,
No,
yeah,
sir.
because
It's
if
not.
you
No,
put
sir.
f of 1, you don't know what will you get as output. Either
No,
you
sir.
will
F
be
of
getting
F of 1 is mapped to two
Yeah,
values.
no, sir.
Sir,
It's not a
because
function, sir.
mapping stuff,
Two
input
the
outputs.
mapping stuff that you are learning, right? You should not see. What I am saying, you should be like thinking of in that way, right? If you are putting f of 1, you are getting 2 outputs. If you are getting 2 outputs, not a function for sure. Okay.
Sir,
So
even
mapping
2 is
stuff,
not mapped to anything. So again, it's not a function. It
no,
does not
that
have
is
its
the
own domain.
difference. No, that is not the case. So let's, for example, 1, 2, 3, 4 has been given to you A, B, C, D. So 1 is mapped to 2, 3 is to D, 4 is to D. Let's, for example, not like this, what you were asking, something like that. This is 1, 2, 3, 4, A, B, C, D. 1 is mapped to here. Okay. See, 2 is not in the domain of a function. Okay. But it is a function. So you can just remove this 2 because 2 is not in the domain. Okay. One more thing I want to clarify. So so this x and y was there. So if in the Cartesian product, you will be having x cross y, some of them are relation, and out of that sum of the relation, there are some of function. So this is one function. Are you be with me?
Yes, sir. Yes.
Yes, sir.
Yes, sir.
The two
Okay.
topic is not.
So there will be a Cartesian product x cross y. Okay, that will be having on 16 element, right? Cartesian product. If 16 elements are there, there can have n different types of relation between x and y. Out of those n different types of relation, there can be some function. This is one of the function f1. This xy, this function, right? When you are defining a function, the element that you can put, okay, in function to get the output, those are called it as a domain of a function. If there are some values, okay, those doesn't satisfy. Like let's, for example, f of 5. What will be the value of f of 5 here?
Nothing.
Not
We don't
defined.
know. We don't
Because
know.
Not
5
defined.
is, yeah,
Okay.
because we don't know whether 5 if I'll put 5 in this function, whether function will be defined or not, that I'm not aware of. So 5 are not the values that you can put in the function. Okay. So whatever values that you can put in the function are those values, those are called it as a domain of a function. Is it clear? Making sense to you guys?
Yes, sir.
Yes,
Yeah.
sir.
Yes,
And
sir.
the expected output, expected. So there's something called expected output and the real output. So what is called expected output and something called real output. See, what is this? This Y is expected or real?
Real.
Expected.
Y is
Expected.
expected. That you can expect. The A, B, C, D can be an expected output. But what is the real output? B, C, D only.
Yes, sir.
You got it, right? So A, B, C, D is a codomain, but B, C, D is the range. Okay. So the expected output is what? The codomain. But the real output is what? The range.
Range.
Is this clear? The all 3 elements are clear for everybody? Domain, codomain, and range.
Yes, sir.
Any doubt? Anybody has?
No,
But
sir.
Sir, domain
No,
is,
sir.
sir, domain is input, and sir, domain is
two.
input.
Yeah, domain is
Expected
input.
output is, and
Yeah.
the expected output is codomain, and real output is range.
Correct. Nice. Yeah.
Still,
So
I have
this
a doubt with
expected
the
output, can
element
you like explain it once more?
Yeah. What I was saying is this is expected output, right? For this function, because this really see this Cartesian product was defined on x cross y, right? But there were out of x cross y, there were some relation that I picked out. Out of that relation, there are some functions. Correct? So for that Cartesian product, this y, so whatever function that I have defined, right? The y can be the expected output, right? I'm not sure whether this is like whether we are getting that as an output or not. If we know about the exact output, that you can tell it as a range. But see, what will happen many a times will be given just x and y, 2 elements set x and set y, where you are writing the Cartesian product, this relation from x to y. The relation from x to y, there are some many relations from x to y, some of them are function. So this y are generally the codomain, where those are the expected output. But whenever you are putting the domain of a function and then whatever exact output that you are getting, becomes the range of a function. Okay.
So
Okay, sir,
can I
got it.
say all the elements of Y are codomain?
All the elements, correct. Yeah, that's correct.
So
Okay.
what I've learned is in the domain, all the elements should be mapped with
X doesn't
codomain.
Yeah.
have its range, then it's not a function.
What?
If any element of X doesn't have any range, then it's a function or not.
Any element, any input doesn't have any output. This is what you're saying?
Yeah, any input doesn't have output.
That input will not be in the domain. See, if you have defining some function, let's for example, you're defining some function. Defining a function, right? Fx equals to x, right? So straight x plus 3 is straight line, right? Having a slope of 45 degree, right? So for this fx, what is the domain for this function? Okay, leave apart. you are
Real
not-
numbers.
Okay. Oh yeah, many of you are.
All real numbers
Okay.
we can
Yeah.
put.
So correct. Any value you can put it. But let's, for example, for some values, for some x1, okay, you are not able to get the output. If you are not able to get the output, that means what? This xi is not in the domain of this function. At xi, the function is not defined. So this xi will not come into the domain of a function. Okay. So if domain is defined for any function, that means there must be an output and there must be a range for that. That there must be some output for sure for that particular value. Okay. Is this
Yes, sir.
making sense? You got it, right? Yeah.
It means, sir, like for every domain, you will have a output. If something is not in domain, or if something is not producing output, then it will be not in domain, right?
Correct. Okay, so I hope we have done with that. So these are all basic stuff. We'll discuss, we'll solve a lot of problems that will give you more clarity. I just want to give you an idea about the different type of a function also, the injective function, surjective and bijective. Even though in the papers, just basic stuff about this all will be asked in the paper, because these all things again will cover in week 5. So from week 5, when you will clarify the paper, the function will be in detail, you'll be discussing about all the different types of functions. As of
Excuse me,
now,
sir.
yeah.
Sir, last question, sir. Sir, in that second example, sir, once please open that slide, sir.
Mhm. This one?
In the example slide, sir. Sir, in the second example, sir, that 2 is not mapping with anything, na, sir. So in domain, sir, we can write it as 1, 2, 3, 4, or 2 will not be
2
countable.
will not be there. 1, 3, 4 is the domain. First of all, this is not a function, but if let's for example, this was a function and 2, let's for example, this case. Here 2 is not in the domain of a function. The domain is 1, 3, 4 of this function. Okay. Let's for example, this is F3.
Okay, sir.
You got it,
And
right?
this function, yeah, okay, sir. Okay. Okay.
So the major thing is done, right? Now the doubt session will be done.
Yeah, major thing is done. If you want, I can cover this injectivity, injective, surjective, bijective. But these all things will be covering again. Okay, so if you want, I can
Sir,
discuss this. Yeah,
Sir,
yeah.
explain in brief.
Sir, I have a one doubt.
Yeah, yeah. Go ahead.
Sir, in the 11th lecture of professor, there is something called how rational number is countable. I don't understand the thing. Can you
Those
repeat?
things will be covering. Yeah, yeah. That is what I'm saying. Next session is totally for the doubt session. We'll be covering there. Okay. There are some lectures
When
in
we have the next session.
what?
When we have next class, sir.
Tomorrow 8 to 10 you have a next session. Okay.
Sir, have we completed the first week?
Yeah, we have completed all the things that are important for your week 1. Okay. In a summarized
Sir.
version. Next session, next 2 session, we'll be taking the doubt and solving more and more problem. Okay. That will give you more clarity about everything. The only left portion is the different type of a function. Okay. The injective, surjective and bijective. Maybe tomorrow session I'll
Sir,
cover.
next session is 8 to 10 p.m. na?
Tomorrow 8 to 10 p.m. Yeah.
Sir, please
Minima,
provide the
maxima is
PDF.
not there.
Sir, I have a doubt.
I'll upload this slide. Okay. I'll upload
Excuse me,
this slide
sir.
and put it in the
Hello.
calendar. Okay. The link. Okay. So you don't have to worry about that.
All right, all right. Thank you, sir, so much
Sir,
for this
hello, sir.
help.
Yeah, so if anybody doesn't have any doubt, you can just leave the call. Somebody who has a doubt, you can just whatever I have discussed today, those doubts only. Okay. And after
Sir,
8,
Am I
after
audible?
10, I'll take any like academic, non-academic doubt you have. When I'll stop the recording, I can take non-academic doubt also. Okay.
Sir, for
Sir.
minimum, maxima is not
It
necessary
will
for
not be
week.
covered. It will be covered in week 3. Yeah.
Okay, sir.
Yeah. Third week
What
will
about
cover
finding the
minimum.
domain and range of a given function? Like they give some function and we have to find the domain and range of it.
Those things we'll be covering with the problems. Okay. I just gave you an idea about domain, range, and codomain. The solution, like while solving some problems, okay, there are some problems in the practice and graded, you might have seen that. Those type of problem will be solving tomorrow and the Tuesday session. Okay.
Okay, sir. Thank you, sir.
So theory
Sir.
part has covered everything. Only the remaining portion are solving some problems and your doubts. Okay. Those we have 4 hours of session, tomorrow 2 hours and Tuesday 2 hours of session. Okay.
Excuse me, sir.
Yeah.
So will you be covering the types of functions tomorrow?
Yeah,
in
we'll be
class?
covering the type of function tomorrow. Yeah, we'll be covering tomorrow.
Sir, how to
Sir,
make
if
notes
access-
for that math?
You can make a not a running notes. See slides, whichever session I'll be covering, I'll be uploading the slides. Okay. And what I'll do is I'll give you one note. So there is one book already there that is written nicely that you can take a help of that. Like we have written that book. It was like whatever has been taught by the prof. If you want more notes, I'm preparing some notes that can help you out. That also I'll attach in the calendar and all. But the book
Sir,
already on the portal, right? There is a book already on the portal, will be of some 150 pages and all. Those are more than sufficient to cover all your notes. So if you are making a notes handwritten, that's like that's the best. But if you don't want to, make many times. We don't want to make a notes. We have already prepared some notes. You can follow that. That is more than sufficient.
Sir, like
Okay,
when
okay,
we
sir.
are doing prof lectures.
We can
Sir,
get those notes in the agenda now, sir.
It's there on the portal, I guess. It's there on the portal. If it's not there, it will be uploaded in a day or two.
In it means in transcript, in supplementary
Not
content.
transcript, not transcript. Those are not transcript. These are proper book type of written, like it's a book written.
Sir,
Okay.
sir, the videos and like you summarized just now, these are pretty basic. The lecture videos are also pretty basic, but the questions in graded assignment and
Yeah.
practice assignments were pretty difficult. So, there was a big gap. So how to understand, how
No,
to
that is what I
transition from
think. So
basic
problem
to
solving session we'll be having tomorrow and day after that. So there we'll be solving the problems, and I don't think so there will be much difficulty you'll be facing. Whatever we have discussed, the basic stuff, if you are clear with that, I hope you'll be able to solve. See, relation problem and all, there are a lot of practical questions which been given. So if you know the reflexive, the unsymmetric transitive basic idea, you'll be able to solve most of the problem. There are a lot of practical aspect has been given. Maybe that's why you are getting a bit.
Yeah.
There are some problems that are difficult. So the graded assignment questions are difficult, really difficult, has been made difficult, so that if you will practice it, the difficult portion in the paper you'll not be having the paper in the paper it will be like a 50% or 60% of the difficulty level that you are solving in the graded. So there are difficult
Useful, sir.
graded, but we'll be solving all those questions tomorrow and day after, like in the Tuesday session.
Okay,
Okay,
sir.
I don't think so
Thank
we'll be facing much issues in the
Yes,
week
please,
starting
sir.
week
Yeah,
and all.
because the concepts are pretty easy to understand, but the questions were so difficult. So,
Correct,
I
that
was
will
struggling.
happen, and this you will face.
Yes, sir. And sir, main problem is that na ki we understood concept easily, but when it comes to apply in the question, we are not we matlab, I not understand where to apply this
No,
concept.
so we'll
What
solve.
this question
So
also.
we'll solve some 20-25 questions. So what?
And
So
practice
that's what I said.
assignment.
There is some problem solving session where we'll be giving you the problem and we'll wait for 2-3 minutes. If you'll solve it well and good, and then we'll start solving. So those sessions will help you
And
those
some assignment.
questions
So
mostly will be from graded
please
assignment.
include some PYQs also, so we get an idea of the
Yeah. See, the
difficulty.
TA session mostly, when your exam will be closer, generally we ask them to solve at least 3-4 terms of PYQ itself with you guys in an hour or something, 1.5 hour. So those sessions we have already scheduled it, but yeah, you'll have to wait for some time. Okay.
Means sir, we will get PYQ session before the exam.
Not PYQs I'll be giving, I'll just ask them to discuss that PYQ. So there are some platform, your seniors and all has created a repository for the paper, all paper. You can find it there, but I don't have it. But I'll ask the TS to discuss those paper. Okay, some paper they can discuss it in the session.
Sir,
Okay?
we
So
have
if you
not
want
such
two
questions or
doubts.
PDFs, can we just like
started.
ask?
You just wait. In coming time, many of the people will create some groups and all, and then they will share everything. So.
Sir, we have not studied in modulus, but in the question, in the
So
given
modulus
option,
and all,
there are
so
mixture of modulus also.
And sir,
Given
in
options,
some
so
question
it's
of
not easy
practice
to solve
assignment.
those questions.
Modulus is just remainder.
Hello, sir.
Yeah.
Hello, sir.
See,
I want to
anything
say
that is
that.
not been taught will not be asked in the paper. That is what I can tell you. Graded assignment, many a times, many people feel difficult, but maybe in tomorrow's session itself, I'll ask the person like I'll to go through some of the PYQ. So when you'll be solving the problem solving session, we'll take some PYQs. That will give you more clarity, more confident, like which type of problems generally is
In
asked.
practice assignment, sir. Sir, in week 1 practice assignment, there are some concept question which are not taught in the lecture. Guide parabola question I get.
There will be some questions. Those are not covered.
Practice assignment.
There are some questions. Those are just for somebody who has already studied maths earlier and all. Okay, so they're not all questions, but very few questions. Out of 20, there will be 3-4 questions. If you are not able to solve, you should not be very underconfident that okay, how will you solve those or not. In the paper, there won't be. I told you right. From the graded assignment, the paper will be some 60 to 70% of the difficulty level. So there are some 2-3 questions that are really difficult. Has been made difficult for some people, like for the practice sake. Yeah, but so that in the exam, even though the paper is in the exam, there won't be that difficult papers and all. You'll just go through the PYQ, you'll get an idea, okay, which type of paper will be asked in the paper.
It's an example.
Even though we have session, right? We have a lot of sessions that we'll be solving all those questions. So you don't have to worry from now. So this is the first session, okay? We have a lot of
Sir, I
sessions
would like
that
to
will
ask.
give you more clarity. I can't come and then start solving the graded assignment in the first session itself, so that from the next session most of the people doesn't come altogether. Okay, so that I can't be doing, right?
Sir, all these live sessions will be available in the YouTube as a
Everything will be
recorded, right?
available. Each and everything that we are discussing, all are available. Just wait for some time. We have just started now. So live session, what do you call live session link of the YouTube? Okay, that also will be uploaded on the portal. Okay, in the form of a sheet, so that you can directly avail it. Or else the best part is in the calendar. I told you, right? I told you in the calendar itself. I will, after the session, I'll just attach the YouTube link, so that somebody can directly go and watch the session. You don't have to go to the seat also. Directly you can just watch it from the calendar itself. Okay.
And sir, we can
Thank you.
get today today class PPT in the
Today
calendar.
PPT, I told you in the calendar, I'll attach it.
Sir, could you make a drive sheet where you can put
Sir,
all the
there is
links
one
and all the
problem.
material
Drive
links?
link only I will upload, so that I'll
Sir,
keep
there is one
uploading
problem.
week-wise all the things. Yeah.
Sir, there is one problem. When I open the mass calendar, it is not showing schedule. But when I open city calendar, it is showing schedule, sir. So, sir, when I will find this, when meeting will be
I don't think
start.
so. This would be a problem. Like I don't know. This is first time I'm hearing this, but okay, I'll check with the operational team why this is happening. But it should not happen. Like you can directly see if you'll go to the portal in the about the courses. There's something called calendar. You just have to click it there and add it to your calendar. If you have added it, I don't think so. All the session will be seen to you regarding maths one. All the TA session, all the maths instructor and TA session will be there. Similarly, you will go to the CT portal, the dashboard of CT, computational thinking, and then there also about the course. If you'll just mark it, there will be a calendar. If you'll add it to your calendar, your personal calendar, the session of the CT will be attached to your calendar, like your own calendar. Okay, the
Sir,
way generally it has been done. Yeah.
sometimes it can get glitch in the attaching.
Sometimes what happens?
So sometimes we can sometimes it might fall to attach the calendar, so I get this kind of stuff.
Okay, I'll check with that, but I don't think so there should be any problem. Maybe with the time you will understand that how to check and all also, because just the beginning, so maybe
Yes,
you
sir, we are new.
sometimes, yeah. So maybe in a week or two, you will be in a position to understand how does it works, everything and all. It's just the beginning, so many a times people get confused how to open the calendar and all. Maybe you're the first time you're handling that, so it can happen. It might have
Sir,
happened
in
to me.
week
also.
I have two
one
doubts.
content,
Yeah.
last four lecture in week one content, last four lecture is just for information, not for
Correct.
exam.
Those are not for paper. Yeah. There are some lecture that will be notified earlier itself. Those are not for the exam perspective. Yeah. So those are just for the understanding. If you want to watch it, watch it. Otherwise, you can just skip it also. There won't be questions as such from those portions.
Okay, sir.
Sir, if one input has one if one input has two outputs, this function
is
is
not a
surjective, right?
That's not a function itself. Leave apart surjective and injective.
But
it's not a function. If one
one
input is
input
two
can have
output,
two
not a
outputs.
function. What? What? I couldn't hear you.
I have learned in somewhere that one input can have two outputs, and this function is surjective. It is correct or not?
No, that's not correct. One input can't have multiple output. That is what I said now. For a function to be defined, one input can't have multiple output. First of all, it should be function. Then only you will decide which type of function. For any relation to be a function or any graph to be a function, for one input, there should be one output. Uniqueness and all I'm not talking about. One output, only one output should be there. Okay, a parabola that you draw, right? A parabola, that's not a function because at one point you are getting multiple output. That's just a relation, but it's not a function. Okay?
Okay.
You got it, right?
And if X is domain and Y is codomain, so what's
Correct.
the range?
Yeah. What's the range? Range
Yes,
is all those values that you will be. So many a times range and codomain can be same, but not in all the cases. Okay? You got it, right?
So if X has 1 to 4 values and Y has 8 A to D values, so what's the range in that?
Range is all those values where, let's for example, a function f1 is putting, if you are putting 1 in the function, what is the output you are getting? F2, what your output getting, F3, F4, all the output that you got from F1, 2, 3, from the
Yeah.
output, the exact output that you are getting from the domain or the range. Okay, and the expected one that you will get it, that maybe from the Cartesian product you would have got it. That is the
So
code
that
expected. Yeah, you are expecting that
range,
output, but the exact output you will get it when you will put the domain in the function. Okay, that's the range.
so then in here, codomain is the range, we can say, right?
You can say that. Many a times it will happen. Codomain and range are same, but not always. There are some conditions where
Oh,
it will not be.
thank you, sir.
Thanks. Anyone else has anything? When I'm feeling hungry, so I'll have to go. So
Excuse me, sir.
yeah, go fast.
Excuse me, sir.
Mhm.
Sir, till the end term for all the upcoming instructor session, will you be the only instructor?
No, there are some other.
There
Yeah,
will be anyone
I'll
else?
just be taking few. Yeah, there are some other. Yeah, so I didn't give my introduction. Like, so I'm Vishal, and I have done masters from IIT Chennai itself, and BTech I have done it from one college in Chandigarh. Okay, and along with me, I'll be having Vilasa and Swati and Sanidhi. So there are three people who will be taking mostly the session. I'll just be taking a few sessions. Okay, there are people who will be taking more sessions like. They're all from maths background. Sanidhi is from PhD, and the other people are from maths background. Masters only they have done it. Yeah.
Okay, sir. One more thing. Can you provide us your email ID, university email ID, sir? We can mail you.
No, I'll provide.
If we have any doubt.
Yeah, I'll provide.
Excuse me, sir.
Okay, sir. Thank you, sir.
Yeah.
I have one last doubt. Can I please share my screen? I have that photo of that that I have doubt of
You can
two
send me on my
two
mail
inputs
ID. I'll
in
reply it there. You can
photo.
send me the picture on my mail ID. I just shared my mail
Sir,
ID.
please, sir, where is
You can just check the chat box. Huh? I just shared it. Okay, you can just mail me there. Huh?
Sir, whatever we practice in assignments in live session, that is enough, sir. Do we need to add more?
No, you have to do the practice and graded also. Okay, those are also important.
Yeah. Sir, qualify exam, how it will be, sir? Paper based or system or MCQ?
The paper will be MCQ, MSQ, and NAT. Okay, if somebody would have written JEE, there are some paper NAT. So numerical value you have to put. Okay, the numerical value can be anything. There's no limitation on that. MCQ are those where only one option will be correct.
Yeah, I
And
mean
NAT are those-
system based only, sir, not paper based.
No paper based, only system based. Yeah. So
Like
you'll be given
like
some rough sheet and all also to write.
yeah,
So
like
how many
MCQ.
question will come from
That
maths?
depends on the paper setter. Okay, but it will be almost like some 15, 16 problem in one hour. Okay. Okay, so I hope that's it from today's session. Thanks everyone for a nice, wonderful session. Okay.
Thank you, sir, so much for patiently guiding us.
Started.
Thanks.
Thank you, sir, so much.
I just wrote
Thank you
my
so
mail
much, sir.
ID. If you have anything, you can just write it down.
And sir, also thank you for sharing
Thanks.
on my ID. So
Thanks.
much,
Sir,
thank you.
tomorrow's class will be taken by you.
Tomorrow, I'm not sure about that. So tomorrow morning, I'll be checking who will be taking the sessions. Okay.
Sir, what will be the
Yes, sir.
timing for tomorrow?
8 to 10. Yeah, 8 to 10. All the session of Maths 1 will be from 8 to 10.
Okay, sir.
Thanks. Thank you and thanks.
They'll be on Saturday and Sundays.
Saturday, Sunday, and Tuesday. Okay.
Okay, sir.
Okay.
Okay, good
Bye-bye.
night, sir.
Good night. Yeah. Good night.
Thank you.
Good night,
Thank
sir.
you.
Okay, sir. Thank you.
Thank you, sir, so much.
Thank you, sir.